In this lecture, we're going to speak about one more very important concept that is actually used throughout AngularJS, and that is dependency injection. I'm sure by now you've seen this construct where we create the module that we're going to use in AngularJS, and we also create the controller with an associated function that is responsible for the functionality and kind of the glue code of that controller to the view. And you've seen the $scope that we pass into the controller's function. But where does this $scope come from? Who instantiated? We've seen that when we do console.log on this $scope, it's a pretty complex object. So who instantiates that object? And the answer is that AngularJS instantiates this object for us. And the way we get that object as part of our controller is through something called dependency injection. So dependency injection is yet another design pattern. We've seen one, model view, view model, and now there's another called dependency injection. So it's a design pattern that implements something called inversion of control for resolving dependencies. So inversion of control is a construct or an approach for resolving dependencies. To understand what inversion of control means, let's take a look at how we usually go about architecting a couple of components in, let's say, a shopping cart. So the regular control would be if we have a shopping cart, we can have a separate module called card proc bank 1, basically a card processing, credit card processing for bank 1 module, and it has one method charge given the number, the credit card number, and the amount. And the reason we have a credit card for a particular bank is because for that particular bank we might have a particular URL that we have to contact the bank through, and that particular bank can have its API. So we don't want to take all that code and stick it directly into the shopping cart, because our shopping cart would be very much and very closely tied, have tight coupling with a particular bank API. We don't want to do that. So the way we would instantiate the card processing is we would create that card processing module inside shopping cart, and then we would just call charge, and call charge giving it the number and the amount. And clearly in this diagram, we see that the shopping cart module depends on the card processing module for bank 1. But what happens if tomorrow we decide that we don't like this bank, or we want to use a different bank because it has better prices for credit card processing fees or something like that? Well, the way we would do that is we would have to write a separate card processing bank 2 that also would have the same type of charge with a number and an amount. And in that case, it means that our shopping cart code would have to slightly change, and now when we create the instance of the credit card processing module, we would have to create it with obviously credit card processing for bank 2. And then as before, we would call that charge method, passing it the number and amount, and here again you clearly see that the shopping cart again depends on this card processing for bank 2 module. But we have a huge problem here. We have to change the code inside the shopping cart, which means we have tight coupling again. Just because we switched which bank we process our cards through, we need to change the code inside the shopping cart. And how do you test the shopping cart? Let's say you only have a couple of simple methods, add to cart and remove from cart. In this scenario, you would have to instantiate a whole credit card processing system just to see if your cart, your shopping cart, can place something into the right array and remove something from that array, keeping counts of total value of the shopping cart, total taxes, and etc. That would be insane. We can of course create a fake credit card processing module and instantiate that instead inside the shopping cart. But that would once again require us to change the code in the shopping cart. And having to temporarily change the code in the very function that we're trying to test seems like a really backwards and a bad idea. Who says we won't mess up something while changing the code for the test and then putting it back the way it was? So what's the solution? The solution is inversion of control. And in this particular approach, our shopping cart function or module accepts a credit card processing module as an argument. And we still have that line where we call the charge method on that card processing module, but it now is using the instance that we were passed from somewhere else. We could still have those separate modules, but in this case, some overall system is going to be the one who is going to instantiate that credit card processing. So in this case, we want to instantiate the credit card processing for bank 1. And then we're going to call, the system is going to call the shopping cart, passing it the new instance of credit card processing for bank 1. So in this scenario, if we need a different bank for card processing, the shopping cart code is left completely untouched. It will not change. This is, by the way, why IOC, or inversion of control, is sometimes jokingly called "don't call us, we'll call you." Because as you could see, the shopping cart no longer calls out to instantiate the card processing module, but instead we, the system, calls the shopping cart module, providing the card processing instance to use inside of the shopping cart. So just to summarize, we learned yet another pattern called dependency injection. For short, it's called DI, dependency injection, which implements an approach called inversion of control. And if you read things online or in other literature, you'll see that inversion of control is oftentimes referred to as I lowercase o uppercase c, so IOC, inversion of control. And in that approach, client gets called with the dependencies by some other system. And in our case, obviously, that other system, that surrounding ecosystem, is AngularJS. And the whole point of it here is the client is not responsible for instantiating the dependency, that other code that it depends on.